Hello everyone, I am Sarian and today I noticed that some of the students are having a hard time dealing with arithmetic and geometric sequences in math. So today I'll be discussing about arithmetic and geometric sequences in math to help you further understand how to identify and solve arithmetic and geometric sequences in math. So first of all, what is a sequence? Sequence is an ordered list of numbers called terms that follow a specific pattern or rule. And there are two types of sequence. The first type of sequence is called arithmetic. Arithmetic sequence is a term-to-term rule which is either by adding or subtracting numbers in the sequence. You can identify an arithmetic sequence if the pattern is by addition or subtraction. Example 3, 6, 9, 12, and etc. So we can identify this as an arithmetic sequence because the pattern here is by adding 3. And if you try to find the next term, it would be 15. But if you try to find the 50th term, it would be a hassle, right? But don't worry, there's an easier way to do this by finding the n-term rule. N-term rule is a formula used in sequences to find the value of any term at its specific position denoted by n. And to find the n-term rule, the formula looks like this. A n equals to a1 plus the quantity of n minus 1 times t. So, you might be wondering, what do some of these symbols even mean? Well, AN means the nth term position, and A1 means the first term of the sequence, and N means the position or the term that you are looking for. The position. And D is the common difference or the pattern. Difference. So if we simplify this and substitute all the values, it would look like this. A and we will not replace this with 50 because we're trying to find the nth term rule. So equals to A1, the first term, which is 3, plus the quantity of n minus 1. We'll not substitute n here because we're trying to find the nth term rule. And times 3. So let's simplify. Distributive property. So an equals to 3 plus 3n minus 3. So add similar terms. 3 plus negative 3 equals to an equals to 3n. So this is the n term rule. And if we substitute n for 50 because we're trying to find the 50th term, it will be like this. A50 equals to 3 times 50. So 3 times 50 equals to 150. So that means that the position of the 50th term would be 150. But there's another way to solve this actually. And this is the other way to solve this. We will substitute the value of n already. So A50 equals to 3 plus the quantity of 50 because 50 we're trying to find the 50th term or position minus 1 times 3. So 50 minus 1 equals to 49. 49 times 3 equals to 147. And then 3, 3 equals So 3 plus 147. So 850 equals to 150. So if you use any of this formula, if you use this formula or this formula, you will still arrive with the same answer. And if I suggest you use this formula if you're just trying to find one term, and this formula if you're trying to find many terms. The second type of sequence is called geometric. Geometric sequence is a term-to-term rule which is either by multiplying or dividing numbers in the sequence. You can identify a geometric sequence if the pattern is by multiplication or division. Example: 3, 6, 9, 12, 24, and etc. We can see that the pattern here is by multiplying by 2. So this means that the sequence here is geometric. And if you try to find the next term, it would be 48. But because if we're following the pattern, 2 times 24 would lead to 48. But if you try to find the 10th term, let's use the nth term rule. The nth term rule for arithmetic and geometric sequence is different. For geometric nth term rule, it looks like this. Okay, n equals to a1 times r raised to the power of n minus 1. So you might be wondering, what is r? R means the common ratio or the pattern. If we simplify this, it would look like this. An equals to a1, which is the first term of the sequence, t times r, which is the pattern, which is 2, and n minus 1. So this is how you will find the nth term rule for geometric sequence. And if we try to solve for the 10th term, we will replace n with 10. So a 10 equals to 3 times 2 raised to the power of n minus 1 will lead us to a 10 equals to 3 times 2 raised to the power of 10 minus 1. So a 10 equals to 3 times 2 raised to the power of 9. So a 10 equals to 3 times 512, and 3 times 512 is equals to 1536. So the formula, so the 10th term for this sequence is 1536, and that's it for geometry. I prepared some questions for the following sequence, so let's answer them together. Sequence 1, 12, 16, 20, 24, and etc. These are the following questions. A. Is the sequence arithmetic or geometric? B. Do you see a pattern? C. How were you able to know the next terms? D. What is the nth term rule? E. What are the next three terms? So let's start off with A. Is the sequence arithmetic or geometric? Since the pattern here is by adding 4, so we can identify this as arithmetic because it involves addition. Do you see a pattern? Yes, by adding The pattern is by adding 4. How are you able to know the next terms? By following the pattern of adding 4. What is the n term rule? So let's solve for the n term rule. So an equals to 12 plus n minus 1 times 4. So let's simplify. Distributive property an equals to 12 plus 4n minus 4. Add 12 and negative 4. So an equals to 8 plus 4n. So this is the n term rule. So what are the next three terms? So let's let's substitute this value of n to 5 because the missing numbers are 5, 6, and 7, and we'll start off with 5. So a5 equals to 8 plus 4 times 5. So a5 equals to 8 plus 4 times 5. 4 times 5 equals to 20. 20 plus 8 equals to 28. So the fifth term is 28. 28. Let's find the sixth value. A6 equals to 8 plus 4 times 6. A6 equals to 4 times 6 equals to 24 plus 8 equals to 32. So 32. And the last term we'll be trying to find A7 equals to 8 plus 4 times 7. 4 times 7 equals to 28 plus 8 equals to 36. So the next term would be 36. So the next three terms would be 28, 32, 36, and etc. So let's move on to the next sequence. For sequence number 2, 1, negative 5, 25, negative 125, and etc. The following questions is the same for the last sequence. So let's start off with A. Is the sequence arithmetic or geometric? Since the pattern here is by multiplying by negative 5, so we can identify this as geometric. Do you see a pattern? Yes, by multiplying negative 5. How are you able to know the next terms? By following the pattern of multiplying by negative 5. What is the n term rule? So let's solve. an equals to 1 times negative 5 raised to the power of n minus 1. So that's the n term rule for this sequence. What are the next three terms? So let's solve using this n term rule. So an, let's substitute n for 5 because the missing terms are 5, 6, and 7 equals to 1 times negative 5 raised to the power of 5 minus 1. So a5 equals to 1 times negative 5 raised to the power of 4. So a5 equals to 1 times 625. So the fifth term would be 625. Now let's solve for the next term, which is 6. A6 equals to 1 times negative 5 raised to the value of 6 minus 1. A6 equals to 1 times negative 5 raised to the power of 5. A6 equals to 1 times negative 3,125. So the sixth term would be 3,000 negative 3,125. 3,000 negative 3,125. Now let's solve for the seventh term. So A7 equals to 1 times negative 5 raised to the power of 7 minus 1. So simplify, A7 equals to 1 times negative 5 raised to the power of 6. A7 equals to 1 times 15,625. So the seventh term would be 15,625. 1,625 and etc. So the next three terms would be 625, negative 3,125, and 15,625. And that's all for today's video. So don't forget to hit the like and subscribe button down below and see you next time.